So what we did last time, we discussed simplify logic expression using Boolean algebra. And then later, we will also discuss there's another technique which we call Carnot maps. So why we have to simplify logic expressions? First, we need to simplify our circuit designs. By simplify means we are going to reduce number of bits that we need to create the circuit. Circuit component pramane adu karna. That means it will reduce the cost and it also reduce the electricity. You can circuit simplify වෙනවා කියන්නේ cost එකත් අඩුයි, electricity consumption එකත් අඩුයි. So there are a couple of things that we have learned under this. We learn laws of algebra, Additive law, which means when you multiply Boolean variable with the same, you will get the same variable. Like if you take A dot A, that means Boolean multiplication with the same variable, which will give you a same variable. Similarly, we have seen that A plus A equals A bar dot A bar is A bar dot A bar plus A bar is A bar. So these things we have seen by drawing truth tables. Then identity law, which means when you multiply any variable with Boolean 1, you will get the same variable. So we get 1 dot A equals A. Then we have a 0 plus A. That means if you add any variable with Boolean 0, you get the same variable. Similarly, if you get 0, and if you multiply this with the Boolean variable A, you'll get 0. Similar to in mathematics also, when you multiply anything with 0, you will get 0, right? Similarly, 1 plus A, you will end up getting A. Then we discuss inverse complement law, which has two forms. First of all, multiplicative form, which means when you multiply a variable with its complement, you will get 0. So for example, when you multiply A with A bar, you will get 0. Similarly, there's another form which we call additive form. When you have a variable with its complement, if you add those two, you will get 1. So for example, A plus A bar should be equal to 1. Then fourth one is very important. Highlight this again, very important. This is called De Morgan's law. Many of the times when you want to simplify Boolean expressions, we have used De Morgan's law. De Morgan's law තමයි පුතේ අපි මේ ඉගෙන ගන්න ඔක්කොගෙම වැදගත් මේක පුතේ highlight කරලා තියාගන්න. So for X, there also we have multiplicative form and additive form. So in multiplicative form, when you have A dot B bar, we can break into 2 as A bar plus A B bar. Similarly, in additive form, when you have A plus B bar, which will same as A bar dot B bar. Then fifth one, we have double complement law. A equals A double bar. That means you get complement of a variable. And if you have a complement, that which we call double complement, you'll get the same variable. So A is equals to A double bar. Right. Then 6 we discussed. Right. 6 we have discussed. Right. Commutative law. In commutative law, we have discussed again two forms, multiplicative form. A dot B is equal to B dot A, which means when you have Boolean multiplication, you can switch the variable. So A dot B is also same as B dot A. If you look at the additive form, similar, you have A plus B, which equals to B plus A. And last time we stopped here, right? Associative law, isn't it, Kanta?
Yes.
Yes, so we have stopped last time with associative law. First form, we have discussed multiplicative form. When you say A dot B dot C is equal to A dot B and then dot C. Let's start today's session. Start with additive form. In additive form, we have, if you have like three, Boolean expressions, we have A plus B plus C, Boolean variables, and A plus B plus C is equal to A plus B. First you do this and plus C. So let's take down this one and let's draw the truth table. You can send me the answer through WhatsApp. Right, so we can do the same time. Right, so when you want to get A plus B plus C, we know that we have to have three variables. That means A, B, and C, which we will have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and we have 1, 1, and 1. Right. Now that we have A, B, C, we can have B plus C. Right, let me put B plus C, right? And then let's have A plus B. And finally, I'm going to have A plus B plus C. Yes, then A plus B plus C. Right. Right. Please fill this and send it to me. Find B plus C, A plus B, then A plus BC, then AB plus C. You should see that these two are the same. Right. So we are going to talk about next distributive law. That means when you have expressions like A dot B plus C, it's like in Boolean expressions. You have done the same thing in mathematics. Similarly, you can expand this by multiplying A with B plus A with C, similar. So this is called distributive law, right? So let's take down this and let's draw the truth table. You can share me the truth table. Right. So in distributive law, what we say is we have A, B, C. Let me copy from here. So the eighth one, in distributive law, what we want is A dot B plus C. So we can have B plus C like in early, right? And then we can have A dot B, then A dot C. So now as the final step, you can multiply A with B plus C. And then next one, you can have A dot B plus A dot C. Right. Let's try to finish this. Let's grow. So here is what we have. We have to have A, B, C. Find what B plus C is, what is AB is, what is AC is, A dot B plus C. Finally, you should see these two are the same. Okay, Kanta, can you... right, B plus C, we know this is 0, this is 1, 1, 1, and this is 0, 1, 1, 1. A dot B, meaning multiplication will be 0, 0, 0, 0. Then we have A dot B again, 0, 0, and 1, and 1. Similarly, when you multiply AC, so you will have 0, 0, 0, 0. And when you say AC, we have 0, 1, 0, 1. Right. Then you multiply A with, B plus C. What will happen is you will get 4 zeros, the first 4, right? And then what happens is it will be B plus C. So that means you will have again 0, then you have 3 ones, isn't it? Yeah, see whether we can do this by adding these two columns. So we'll have 0, 0, 0. Fourth one is also 0. This is also 0. And after that, everything is 1, right? So I can see that you also get the same answer. Right, good. Right. So this is called distributive law, right? Okay, similarly, the last one that we are going to discuss today under the laws, right? It's the 9th one, and this is called redundancy law. Again, this has like, two forms. The first one, if you have A plus A dot B, It says basically it's A. You can actually use truth table to identify this, or simply you can, if you take A out, this will be 1 plus B. From the previous knowledge, you know, when you add 1 with any variable, you will get 1. So basically you left with A, right? So let me type it for you. So if I, right? So this is what I said. One way to solve is we can try to simplify dot B, meaning like we know A is common, you take it out, then we'll have 1 plus B, right? Now what happens always when you have 1 plus B, meaning you add 1 to any Boolean variable, you get 1. So that means you will get A. But you can use this our previous method, which means we can also use a truth table. අපි අර කලින් කතා කරා වගේ මේකෙදිත් අපිට truth table එකක් ඇඳලා මේක හොයාගන්න පුළුවන්. So let's explain that one as well, right? Yeah. So here I'm going to have like 2 variables, A, B, then A dot B, and finally A plus A dot B. So let's see, right? What will happen? Now that we will have, let me draw the lines to separate the two tables. We have A, we have B, we have A dot B, A plus A dot B. So this is exactly what we are going to do, right? Now that we said A, we will have 0, 0. Then we have 0, 1. You can send me the answer if you finish early, right? Then we have 1, 0. Then we have 1 and 1. Now let's multiply AB together. So you'll get 0, 0. This is also 0. We have 1. Now we'll add A to this. So that means 0, 0, 0, 0, adding, no change. But when you say 1, 0, you will have 1, 1. So now you can see these two are identical. This one and this A plus AB, both are identical, right? Both are identical, which means that this is B is redundant, right? B is redundant. So that's what we call this redundancy law. This is called redundancy law. Okay, so the next one we call redundancy law. The second form says A plus A bar B equals to AB, right? So which means what we need to do is, right? We are going to get, first of all, A and B, right? Then we need to have A bar. Then we can have A bar B, right? Then we can have A plus A bar B. Then we can have A plus B. Right. So now I'm going to take the pen. Right, so we have A, we have B, we have A bar, we have A bar B, A plus A bar B, A plus B. So the values are, we know, we have 0, 0, we have 0, 1, we have 1, 0, we have 1, 1. Right, what is A bar? So we know what is A bar is 1, 1. This is 0, 0. Now we have to multiply A by B. So this is 0, this is 1, this is 0, right? This is 0. Okay. Now you add A to this. When you add in, this will be 0. This will be 1. This will be 1. This will be again 1. Add A, B together. We also have the same answer, right? 0, 1, 1, 1. Right. Right. Were you able to visit the website?
Yes.
So you can go to logic.ly demo. So using this one, you can form small circuits and see how they works, right? There are some switches, buttons, clocks, bulbs, right? And the logic gates. Since we are discussing logic gate, let me start with, first of all, O gate. So you just drag it like this. We have O gate, we have 2 inputs, right? And then one side input, I'm going to use 2 switches, right? I'm going to say this is A. And then I can connect this, right? I can connect like this. And we have another one, 2 switches. I'm going to connect this and also to this. So now let me put a bulb. Bulb is also connected. Now what is this gate, Kanta?
Okay.
O gate. So what will happen in O gate?
Output true and output input true and output true.
Exactly. So right now there's no inputs. So white color, then bulb is also in off state. But when you switch on one switch, you can see power is connected and the bulb is in ons, right? Similarly, you can have only the first one, then also you get the same, or you can use both. Okay. So in this circuit, you can see when both switches are off, the bulb is off. When one of the switches is on, the bulb is on. When both the switches are on, yes, bulb is on state. That's what you need to remember. If you want, you can change the gate, right? Just I can remove this. Let me, delete this. Yes, I can delete. There's no O gate. I can put AND gate, right? Connect the 2 inputs, connect to the output, right? In off state, right? Now, you can continue. I will explain this one more time for the recording. So this is AND gate, and here's how we use NAND gates to create AND gate. So what we did, we will have a NAND gate. We will put a NOT gate to get AND gate. So how do you make it a NOT gate? You should just short circuit this, meaning like you will have the same inputs. So if you do the same, when you switch on one switch, bulb will in off state, nothing will happen. Try other way around, no switching. Now let me put both switches. You can see light is on. So we can verify that using this circuit builder, simple tool, right? AND gate. We can create an AND gate using 2 NAND gates, right? Try all the other gates. Right, now look at this circuit. In this circuit, we have 3 inputs, A, B, C. And you can see that there are like 3 and 2 O gates. Altogether, we have 5 gates and we have a bulb Q. First task, I want you to come up with a Boolean algebra expression for this circuit. So let's start the expression. So I will say this is A. And this is B. And this is C. And we know that the outcome is Q. We need to write an expression for Q, right? We need expression for Q. Expression for Q. Now let's start. Now, first thing we know, we have A here, B here. So this is the AND gate. So we will have A dot B, isn't it? And here we have B and C. And this is O gate. So we will have B plus C. Here again, we have B dot C, right? And then these two, we have another NAND gate. So that means we have a B plus C, right, dot B dot C. So this is what we have. And this is AND gate. So Q, we can write down equals A dot B plus B plus C into BC. Isn't it? Kanta? How did they make it? Right. Now that we know this is the equation, now we know how to make use of Boolean laws. So what are we going to do? We are going to make use of all the things that we have discussed so far, right? So let's see how we can improve this. Improve meaning like try to simplify this, right? So let's start. So the first thing that I'm going to do is I'm going to expand. We have A dot B plus, okay, here we have B plus C and dot B dot C dot. So we can multiply, we can simplify by removing bracket, multiply BC with B. So that means first term B dot C plus we will have C dot B dot C. So this is equal to A dot B plus, from the theory, we know what is B dot B. B වලින් ගුණ කරාම
B.
B. So we can simplify the second term is B dot C. Then we will have C dot B. We know that C dot B is equal to B dot C. So we can write like this. Now we know this is equal to A dot B plus B dot C plus B dot C means C. Right. Now we have A dot B plus B dot C plus B dot C. May BC වල එකතු කරාම එක මාගේ කීයද උත්තරේ එන්නේ? ඒක නිකන් හරියට A plus A කියනවා වගේ. A plus A කිව්වොත් මොකද උත්තරය ආවේ? A. අන්න ඒ වගේ. A dot B plus, instead of two terms, we can have only one term. Like this. Now we know that B is common. We can take out B dot A plus C. That's all. This is after simplifying the Boolean expression. Now you can, I have built the circuit. I need only two gates here. Now let's check the inputs. We have A, B, C same. No output. We'll try A. No output. We try B only. No output. We try C only. No output. Try AB. Yes. Switch on. AB. Switch on. Try BC. Switch on. Try BC. Switch on. Try AC. Nothing will happen. Nothing will happen. Try ABC. Switch on. See? They are equivalent, isn't it?
Yes, sir.